The last section of Chapter 10 on polynomials deals with scientific notation. It's not exactly polynomial material, but it does deal with exponents, and so it does relate to the chapter. Scientific notation is a way for scientists to represent really big numbers or itty-bitty numbers. Okay? Scientific notation is always in the form of some number m times 10 to the nth power. Okay, so every single scientific notation number will have this times 10 whatever in it. Now, what can I say about m and n? M is a number that's between 1 and 10. M is always a number between 1 and 10. It does not include 1 and 10. It's a number, well, it includes 1, but it does not include 10. Okay? So it's a number between 1 and 10, not including the 10. So in other words, it has to be one digit, 1 through 9, and then a decimal point. So examples of what the m could look like, it could be 2.4751. That's a number that's between 1 and 10. It could be 6.89024. It could just be the number 8. It could be 7.14. But it's always going to be one single digit and then your decimal point and any other significant digits after that. The n is either going to be positive or negative. If it's positive, it means that we have a really big number. Because remember, we're taking it times 10 to that many, times 10 that many times. So it makes it a big number. If it's negative, as we talked about before, a negative exponent really means that we are dividing. And taking some number and dividing it makes it itty bitty. So if n is a negative, we end up with a small number. Now, what does this all mean? Why does it have to have that times 10 to this stuff? Well, that's because multiplying by 10 just moves your decimal point over. Now let's face it, scientists deal with really large numbers. Think about all the studies of the universe. How far away is the sun? How far away is the next galaxy? All of these as possibilities. You have to keep that in track that, let's face it, when you get to be billions of light years or miles away, what's a few extra 100 or 1,000 here? So that's why we don't necessarily have exact measurements. We also can't find those. But if I had something like 9.45 times 10 to the 8th, okay, that's a scientific notation number. Every time we multiply by a 10, and there's 8 of these, 10 times 10 times 10, etc., it would move your decimal point over, making the number 9.45 larger and larger and larger. So this is the scientific notation number. To write the decimal equivalent to that, we move our decimal point to the right, because every time we multiply by 10, it just moves the decimal point. We move the decimal point to the right 8 times. So right now I have 9.45. So that would be moving it 1, 2, and then we need 6 more. 3, 4, 5, 6, 7, 8. So we move it 2, 3, 4, 5, 6, 7, 8. And so now the decimal point is over there. Because we expanded this. We took the 10 times itself 8 times, which only moves your decimal point. So 9.45 times 10 to the 8th is the same thing as 945 million. So to convert the scientific notation number to the decimal, we move the decimal point n times, and because n was positive, we move it to the right. Okay. If n was negative, we'd move it to the left. So if I had 2.165 times 10 to the negative 7th, that means that this is an itty-bitty number because I'm dividing by 10. How many 10s am I dividing by? 7 different 10s. Not the number 70. I'm dividing it by 10 times 10 times 10 times 10 times 10 times 10 times 10. Ooh. Okay? So that makes it itty-bitty number. So I still have that the number 2165, So all of those digits don't change, but then I move it over. Now when you're moving it this direction, it's going to be 7 spots, negative, so we're making it smaller, so we're going to move it to the left instead of the right. The first spot moves us in front, and now I have 6 more, so that's how many zeros go in front. 1, 2, 3, 4, 5, 6, and then your decimal point. You can always check that to make sure that you didn't count incorrectly. It was 1, 2, 3, 4, 5, 6, 7 spots. So the decimal point is now in front. So we have 0.0000002165 is what this number represents. So here the exponent was negative, so we move the decimal point to the left. Right. Now remember, this is converting from scientific notation into a decimal number. So from scientific notation to decimal. If it's a positive exponent, we move to the right. If it's a negative exponent, we move to the left. Which means that if we're going from decimal notation to scientific notation, it's going to be the reverse. Let me show you some of those. All right, write the decimal number in scientific notation. And they give us this big number. Okay, right now, in a really large number, where is our decimal point? Oh, well, a really large number, our decimal point is here at the end. I need to move it so that it's between 1 digit and then your decimal point and then the rest of your digits. So when I read my number from left to right, it's going to have a single number, then the decimal point. So as I'm looking at my number, it's a single number, 8, and then the decimal point. Then I need any significant digits. I need the 2. I need the 0 because there's a non-zero number after that. But now that it's a whole bunch of zeros, we drop that off. Then, because it's scientific notation, I must have times 10. Because in order to move a decimal point, it's because you are multiplying by 10. The exponent never goes on our number here. Okay. And now we get to count. Yay, love to count. Okay. And we go through and we say, okay, my decimal point is over here. I need to move it so it's between the 8 and the 2. How many spots is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. One more makes 10. Oh, and another one. So that's 11 or 11. It's a big number, so our 11 is positive. So 8.204 times 10 to the 11th is this big number written in scientific notation. So we moved our decimal point from the end to the left. So when we went from decimal to scientific notation, okay, moving your decimal point to the left, means positive exponent on the 10. All right. Before, when we moved it to the left, it was in the other direction. When we had a decimal, or when we had scientific notation, we moved to the left when we had a negative. Now it's reverse. Let's do another one. What if I had this tiny number, 0.000063? Now in Science City, the big city that Mathland is a suburb of, they oftentimes use the 0 in front so that they clearly see it all. We in Mathland, we don't necessarily feel like we need to have that 0 in there. We know that the decimal point means that there's a 0 in front of it. Do whatever you're more comfortable with and whatever you see. Okay. So we need to move this, once again, the decimal point, so that I have 1 digit and then my decimal point. So that digit is going to be the 6, then the decimal point, and then the 3, because that's another significant digit since it's not a 0. We have to have times 10 to the, because this is writing it in scientific notation. And now we count. We moved 1, 2, 3, 4, 5, But the number 0.000063 is an itty bitty number, which means that our exponent will be negative to make it smaller. Okay? So when we're going from decimal to scientific notation, and we move the decimal point right, means we have a negative exponent. And remember, the exponent is only on the number 10. All right. So to convert from decimal to scientific notation, if you move your decimal point to the left, you have a positive exponent. If you move your decimal point to the right, it means you have a negative exponent. And once again, it's reverse if you're going in reverse. And that's what I have to say about scientific notation. Have a good week, and don't forget to study hard for your final.